Hey everybody, this is Larry. This is day 22nd of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And we have a weekly problem, so check that out afterwards. Today I just kind of rested, but mostly just doing running errands before my trip and got my camera ready and stuff. Got a new lens. I don't know how I feel about it. It's actually the old lens, but a little bit smaller, and I paid so much money for it. I don't know how I feel about it, but yeah. Cameras or photography, very expensive hobby. Don't recommend it. Just use your iPhone or Android phone or whatever. Anyway, I guess if you want to check it out, I have my Instagram in the description. Check that out if you want to see my photos. They're very expensive, so I hope someone likes them. But anyway, yeah, let's take a look. We have 2338. Count the number of ideal arrays. You're given two integer n and a max value, which are used to describe an ideal array. A zero-index integer array of length n is considered ideal if the following condition holds. Every array sub I is a value from 1 to max value. From 1 to max value. Okay. What? Maybe. I don't know. Okay. Every array sub I is divisible by I minus 1. Okay. Return the number of distinct ideal array of length n and mod. Alright, let's just do the mod first so that I don't forget. That happens a lot. Mod. I have a mod song. Okay. Okay. What are the numbers, right? So n is 10 to the 4th and max value could be 10 to the 4th. Okay. What's max value again? Oh, is 1 to max and divisible, right? I mean, my initial thing would have been to do dynamic programming, and it might still be. But, but naively speaking, 10 to the 4th times 10 to the 4th would be too slow. But I don't think a lot of those states are possible. Right? They have to be exactly n elements. Oh, yep. I don't think a lot of those states are possible. Right? I guess it depends how you write it. Anyway, no, a lot of those states are not possible because this divisible part is really weird, right? I guess if you're naive, it could be possible, but let's see. But the thing is that you can have stuff like this where it's just all the same number. So that's the tricky case, right? So okay, so what do I mean, right? Okay, let's write it out. I don't know. I don't think this is good enough yet, but we can kind of write it out to kind of explore, right? This is why I do it for a lot of dynamic programming problems and see if I can maybe see a pattern, optimize, or whatever, right? So here maybe we have I don't know. I'd name every DP Go just so that I don't have to spend too much time thinking about the name. But okay, but let's just say naively we have index and we have last value, right? Of course, as we said, index can go from 10,000, right? And max value or current can only go up to max value, which is also 10,000, which is going to be too slow, right? But can we find some ways to think about this? I don't know. We'll see. Well, if index is equal to n, then we're done, right? So we return 1. Otherwise, and this is assuming that this has all of one state, which honestly, maybe not, right? Like maybe, yeah, I mean, like we were talking about really naively. And by the way, all of these are usually filmed live, so clearly it's filmed live because otherwise I'm just really unprepared if I knew the answer and don't know how to say it. But no. So I don't know the answer right now, right? So I'm just trying to figure out. So my apologies if this is not to the point, but I think for me, like there are probably a lot of videos on this problem, and I solved this. So maybe I have a good video on this problem. I don't know. I don't know what past Larry did. I don't remember this one. But I want to show you how do I approach these problems live when I don't know how to solve it. And I think that's unique for me and interesting. Maybe, maybe not. If not, then you just watch the other video. Probably the older Larry is better. But yeah. Anyway, so naively, maybe we can do something like go of index plus 1. We have like current times I, for I is from 1 to some big number. Of course, you have to just make sure that current times I is less than or equal to max y. So something like this would work, right? But of course, it is going to be too slow. But it would work, right? Kind of, maybe. Right, give or take. Because you just go 0. 1, right? And this isn't even quite right because you're supposed to do a for loop on this one as well. I'm going to say the first number, but you can see that, did I mess this up? I feel like I messed this up. I mean, I don't know. Okay, maybe this is just really lucky. Did I accidentally get it right? I don't even know. How am I? Okay. I'm so good I accidentally cannot stop myself from getting it right. No, I'm just kidding. But the reason why I don't think it is good because I think this needs a for loop, right? Because the current number... Oh, I see. Because... Okay, I guess I see. I technically I have an off by 1. I think that's why, because 0 is so this is the first number and this is the loop on the first number. So okay, so this is right, but of course it's gonna be too slow, right? That's just the way it is. Even if you cache it, right? I just add the memorization. I'm not gonna go over memorization today, but yeah, even if you cache it, it's gonna be too slow, and you could just kind of do 10 to the 4, 10 to the 4, right? Just play around. Though that said, I'm not gonna lie, this is definitely too slow because it definitely reaches all the states and there's a for loop inside, right? But you still gotta prove yourself wrong. There are a lot of these problems where, I mean, this one I think is too obvious, but there are problems where sometimes because you're doing it top down, it doesn't visit all the states, and because it doesn't visit all the states, then all the states are possible, right? Or like there are a lot of impossible states get automatically filtered out, and then maybe you go fast enough as a result. That's not gonna happen here, but give yourself room to be wrong just to kind of see. But okay. So of course this is too slow as we suspected. What can we do? There are a couple things that we need to do to kind of get it down, right? If nothing else. If nothing else, we have to get rid of either one of the dimension to begin, because this is too slow in 2 different ways. But we have to get rid of one of the dimension or one of the or the for loop in general, right? I'm trying to think. I'm trying to think. How would I do it? I don't know that that's that easy to index current or index. And I'm trying to also think whether like this is a combinatorial problem thing, and then try to figure it out. Like maybe we can just merge all the ones, right? For example, as an example, but and yeah, and just ones and twos they're already. So make okay. Well, then that's an idea, right? Meaning that okay. Let's say we have n numbers, right? And we're just trying to go through all the distinct numbers. And then it just becomes, okay, you have n numbers in a bucket, and then you have like, what's it called? Bars and stripes or whatever it's called, bars and stars. But basically you're putting n bars into 4 buckets in a way such that they all have at least one element, right? Or something like this. Of n, you have n bars and then the number of distinct elements, and then you just try to do some math on that, right? And the reason why I suspect that's much faster is because now you don't have to deal with the ×1, right? And the reason why ×1 is important is that it fills out all this time order thing, right? If we don't have to do that, then what happens? Well, if we don't do the ×1, then everything has to be at least multiplied by 2, right? And we multiply by 2, then 10 to the 4th is what? I don't know. Is that like 13 or something? 14? I don't know. Whatever it is. 13, 14, right? That means that you can have at most 14 numbers. And as a result, then now you have n choose. It's actually n minus like k over k or something like that. Or n over k choose k or something like that, where k is the number of distinct elements or something like that. And we could go over that mathematical thing later. I'm trying to think whether that sounds right. But yeah, but as a result, you have at most 14, 15 numbers, and that should be good enough because then it is just right. I mean, we can write that as well. Let's see. At least just to play it out. I want to keep the mod. That's why I want to. Yeah, I'm going to forget. Right. So here maybe we can have Jen. Right. We have. How do we want to write it? No, I mean it's just what you might call it, backtracking, right? So then maybe we can write something like so here's the current. I don't know if stack is the right word for it. Maybe array here. I mean you treat it like a stack anyway, right? And we start at. I guess we don't always have to start at 1. I mean you could do it with 1 and then ignore the first number or something, but I don't know. Fine, let's just do a for loop so that is less confusing for everybody, right? So here maybe you have for I in range from 1 to max value plus 1, right? Then now we start with an array. I don't know. I actually don't know if it's faster to append and then pop or the other way, or just to allocate every time. If I have to guess, allocating is a little bit faster, but I don't know, right? So then now we can go, yeah. I'm trying to also think, sorry for a second. I'm trying to think about it in terms of, like I could do a for loop, like, yeah, we can do a for loop, like for I in range from 2 to max value plus 1 or something like this, and we'll break early, so it's fine. And then like previous value is you go to array sub I, right? So we can definitely do this. Right. The reason why I haven't, and we have to add something for checking stuff. And this is just a very standard backtracking, right? From 2 to, and you've, and all the number, oh, actually this is kind of wrong. I don't know why I wrote it this way. 3 times I, but only if P times I is less than max value, something like this, right? That should be fine. But the way that I'm thinking about it is actually something Sif-like, which is why I'm thinking about, right? If you think about it, and maybe this is fine. I don't know if this is true, but you can think about it as actually this is kind of like Sif, right? Because now this is on the last number. Okay, maybe it is. It's just written a little bit weirdly because I have because I chose to word of modification. Yeah. Okay, so you could. Yeah, so you can maybe even write it like this, right? So while current is less than you're going to do, right? Then now actually current P times plus P, right? And then current we added by P, right? So oops. Yeah, no, this is fine. But basically, this is like a Sif if you kind of visualize this out, right? Because, for example, if the last number is 1, it goes all the 1s. And then on 2, it goes all the 2s. and then on 3 it goes all the 3s, right? Is it though, Larry? Because we double count, or it's not quite that, because we do the math on, like, for example, 6 multiple times, because 2 goes to 6 and then 3 goes to 6, right? Where in a CIF, 6 is only executed once. But we can take advantage of what we just said, right? We can just do a reverse CIF, right? Like here, I know this is a really weird way to come about this, and sometimes you just have to do things the weird way, and the weird way is better than no way, right? But the way that I would now think about it, right? Actually, I mean, maybe that's true, but let me see if how fast this is. Let me see if this times out. Don't prematurely optimize, right? So we already have this input in, so let's kind of take a look. Oh, what? Where? Oh, whoops. This is -1 for the last element. Why is my... If it times out, right? Then we'll figure out something else. But as you can see, I mean, it's not fast, but it runs, and this would be the max case, right? 10,000 would be the max case. So it runs. We do have to do a little bit more math, so it's going to be a bit slower. But maybe we could have a chance. Yeah. And the reason why you can like do memorization on the last element or something like that, which I thought about, is because we require okay. Actually, I think one thing that I just now realized is that the number doesn't matter, right? I mean, we need it for this generation, but in terms of counting the number of pairs or number of combinations, and what we're doing now, or what I'm trying to do now is, okay, let's just say we generate, let's say max value is equal to, say, 8, right? N is equal to 10, and we generate 1, 2, 4, 8, right? Yeah. And then now that means that we have 10 balls, if you will. We have to put in 4 buckets, right? And of course, the 4 buckets, we have to have at least 1 ball in each. So that means that we have 6 balls left, right? And then the number of ways to put the 6 balls in 4 things is just 6 choose 4, right? Is it? Am I messing that up? Is it 6 choose 4? No. It's 6 to the 4th. Yeah. Sorry. Yeah, not 6 choose 4. I said it's 6 to the 4th, right? Because after putting 1 ball in each of these, then now you got 4 ones. Oh wait, no. Oh no. Yeah. With each of the ball, you can have so 4 to the 6th part. I don't know if I said 6 to the 4 or 4 to the 6, but it should be 4 to the 6 because now you have 4 buckets and you have now 6 balls left, right? And it could be any of those numbers to extend the thing. And that's really the idea. But if you keep this in mind, keep in mind that it only matters what the n is and the number of buckets. So as a result, we can, like, we don't, it will be cheap because it only matters the number of elements, and therefore if you do write something like for example, you can write something like, okay, so yeah, so let's say so at every step we have to calculate because we're saying, okay, assuming this is the last element and we end here, right? Then now total we add it by some total, right? Some number, right? And what is some number? Well, that is just the length of P. We can say, so the length of P is the number of buckets we have. We have n minus this is the number of balls we have left. And each of these we can choose the buckets, right? So something like this, right? And we'll put the mod power in here. Int has no length. Oh no, not p array. Whoops. Oh, I have to do negative stuff. I was gonna check for negative power. Maybe that messes things up. Because then now it's doing like modular inverse stuff, right? Okay, it's still wrong somehow. Am I confident about this? Oh, I'm wrong. This isn't 4 to the 6. For the same reason, because every ball is not distinguishable. So that means that now we have 6 balls. We want to put in 4 buckets. So then that is 6 choose 4, right? Okay, let's try real quick. Am I really wrong? Is my math that bad today? I just have to break it out, I think. Is 6 choose 4 minus 1 because you have 3 barriers, right? No. The barriers don't make sense. You have four buckets. Am I confused? I mean, very much so. But I think that's the general idea, though. If I could do the math, that would be great. It isn't close. Okay, let me just debug it. Maybe my math is just so wrong. Okay, so here, let's just say we print array. Oh, jeez. Okay, well. Oh, won't even give me the other one. Okay, fine. I mean, this is right. It is what we want. But it's so half of them is giving 0. Why? We have 2 numbers. Man, today my math is just really bad. This feels like a very elementary math part, but I am wrong. Okay, so you have 2 array. Both are forced, so 0 choose. Did I mess this up? Okay, so n is 2. So then this extra length is 0. 0 choose 2 is 0. Is that what we want? I mean, clearly not, but it's not 0 choose 2 though. That's just wrong. You have 0 balls, you could put it in the 2 things, which is one way, which is the no set. What am I doing wrong? How am I thinking about this wrong? Maybe today I need more sleep. Well, I think in general. I have allergy issues, so I need more sleep in general. I don't know what happened to my quercetin. I need to kind of take some before so I can go to bed early. But anyway, okay. Okay. I mean, clearly my combinatoric today is just left me. But okay, so let's say we have yeah, we have 0 boards left. That should. Because you have to force every. I mean, I want to do an else statement, but I feel like that's just wrong, right? Well, this is just overcounting, so I can't even do a. Because what I want to think is like, okay, maybe if it's 0, we just add 1 or something, but like we do this. But I don't even know if this is right? Because it's overcounting on the other one, so that doesn't make sense. Okay. If there's only one number, so 4 is definitely not right because there's only one way to do this, right? So my math is just really wrong somewhere. Okay, let's step back. Let's regroup and think. Okay, so you have 5 numbers or 5 buckets. They're all choosing one. How many distinct ways are there for 4 things to choose? Oh no, it's not 4 choose 1. That doesn't even make sense. It is bars and whatever, right? So you oh yeah, okay, I'm just being dumb. Then yeah, okay, so because then you do and then is the number of ways to put the thing. So okay, so I'm putting in the barriers between the bars. That's how I should have thought about it. Okay, I am really bad today, right? So okay, so for example, in this case, you have 6 bars, you have 4 things, and we're just trying to put 4 different barriers. And with 6 bars, there are 7 barriers, 7 places to put the barriers. And is it choose 4? It's not 7 choose 4 though, because oh. No, okay. So then if we have 10 boards in general, we have 4 different things. Then now we can do a 4 divider thing where they do not share the same one, and that means that because they do not share the same barrier, it is going to be that. Okay, so then now it is just n bars. Choose the number of barriers, right? And so I mostly had it. I was just dumb. Okay. Maybe not. Maybe still wrong. I don't know if that messes things up. Am I still wrong? Why am I so bad? This is right, actually. This is wrong. What is that? 1 choose. No, 2. So we have 2 bars. And we have oh, it's n minus 1 then, right? Oops. Well, not n, but the number of elements. Wow, I am just really bad at math today. This is wrong because this should be 0, right? Because you have 2 bars and 3 barriers. Sorry, fam. I'm letting people down. I feel like this is like a very elementary, basic thing, but my boss and whatever are not clear. Okay. So this means that we have 1 bar. I was hoping to finish early. I have 1 bar. Oh, sorry, 2 bar. we always have two bars. We have one divider, but it doesn't make sense to have one divider, right? So it should be n minus 1 for this. And if you have two buckets, then we have one divider, right? You have either here, and that's it. Oh, no. Then now, okay. Because the divider cannot be in the beginning or the end because we have to force one element. It is not n on a thing. There's n minus 1 place for the barrier, and we have n minus 1 or minus 1 on the barrier as well. Does that fix things? Okay. I think yesterday I spent a lot of time saying like draw it out. And I think honestly my problem with this thing for today is that I did not draw it out, right? Because as soon as you saw me I didn't draw it out, but I tried to visualize it. As soon as I visualized it, it was quite obvious. But I don't know. I think sometimes you do get a little bit like you use your past experience as a crutch, and I was like, oh, I've seen this pattern before. I know how to do this, Larry. You're smart. And then I was just like, and then you saw how it happened. I keep on doing like off by one things when I'm like, okay, if I just drew it out, look, you have all these boards. You try to put dividers. How many spaces can you put the dividers, and how many spaces there are, right? And then that would make it very obvious. And I think this is mostly right. The reason why I don't want to submit yet is, well, I don't know why. Well, if nothing else, I want to try the big case. But this can get a little bit murky with the. I mean, it's actually not that bad, but you still should mod. I mean, the mod is not the issue here, right? And in fact, it's slower. That's kind of funny. Yeah, but the reason is that this number can get really big, and we probably should time out. So, so the way that I would think about this is also put it in a whatchamacallit, in a dynamic programming, right? And that should be good because and dynamic programming is also good in the sense that it's also good because it's one. After you fill it out, it's just one lookup. And in fact, you probably should put in an array. Let's not do it this way, right? You should put in an array. So then here maybe DP is you go to 1, right? And it's just Pascal's triangle, right? And reason why I'm hesitating is that you have to check bounds now, otherwise it returns 0, but that's fine, right? Where do we go up to? 10,000? Oh, 10,000 may be slow actually, right? Because this is, oh no, because this is like I said, this is at most like 15 or something, right? Oh, that's why this is fast enough. Okay, let's actually we did talk about this, but I forgot already. So yeah. We did talk about this, but I forgot already, which is that the length of array can go up to like 15 or something like that. So that's why this is fast enough, is because it doesn't have that many digits, because it only goes up to 15 or something. But we should still memorize this actually. So we'll just wrap it around a get com thing, right? And then just return this. Yeah, just keep, just to memorize it so we don't have to worry about it. And also we might as well mod it. Yeah, as you can see, it's slightly, I don't know if it's faster, but it is fast-ish. Let's see if it's fast enough. It may time out. If it times out, we'll figure something out. Apparently it passed in 9 seconds. But yeah, wow, people did it really quickly. Huh. I mean, yeah, probably a lot of the time is here. And I think, like I said, you probably can do this in a more Swift-y way. maybe. But I don't know anymore. What did I do last time? This doesn't feel right, honestly. So I'm just gonna. Oh, I did do the thing with the sieve, like I was saying. But this is also ridiculous. Maybe that is the cleaner way of doing. I mean, this is the choice. I mean, I think I end up basically doing the same thing, right? I do the sieve. I do the cap. But past that, we did it in a crazier way. I don't know. I clicked on the wrong answer, but I think that's just like a minor fix or something. I don't know. I don't know how I feel about it. I mean, but as you can see, I definitely did not do it the same way. If you want to check out that video, check out that video. And let me know which one you prefer. I think this one makes sense. It just kind of, for every number as the max value, we try to factorize it. And then if that's the factor, then yeah. Then we just try to do the math that way. And I don't know, maybe it's fine, maybe it's not. Let me know what you think. I don't know what do they intend the answer to be? Combinatorial math. I guess this is more similar to what I had before. But today I guess we did a little bit funky, a little bit different. Let me know what you think. Thanks for watching. And you know, today is not the best, but hopefully it gives you an idea that, you know, there are many ways to do this. Do prompts in general, maybe not this, maybe there only like a couple of ways, but you know, exploration, feel free and kind of just, you know, get up to it. That is all I have for today. Let me know what you think. Thanks for watching. If you watched the other one as well, let me know which video you prefer and leave it in the comment. Stay good, stay healthy, good mental health. I'll see y'all later. Take care. Bye bye.